Welcome to The Explainer. Today, we are doing something totally different, incredibly strategic, and honestly, absolutely vital for your academic success. We're not just going to sit here and crunch math problems. No, we are going to step directly into the minds of the people who actually grade your papers. Think of me as your elite Cambridge curriculum architect. Together, we're going to completely decode the marking rubric for Cambridge AS and A-level mathematics, specifically syllabus 9709. And we're putting a massive spotlight on one of the most notoriously tricky areas on the exam, complex numbers and the precise mechanics of finding the square roots of a complex number. Okay, let's dive into this. Look, if you're a focused learner aiming for those top-tier mark bands, you need to realize right now that success here isn't just about knowing the math. It's about knowing exactly how the examiner expects you to communicate that math on the page. By the end of this session, we're going to break down the exact playbook you need to secure every single available mark.
15%. Now, you might be wondering why this specific topic. Well, did you know that evaluating the square roots of complex numbers, along with their associated operations, accounts for approximately 15% of the total marks in Paper 2 of the Cambridge 9709 mathematics exam? Just let that sink in for a second. 15% is not some tiny drop in the bucket, it's a massive chunk of your grade. It is the ultimate deciding factor. We're talking about the literal difference between settling for a B and securing a clean A, or jumping from an A to an A star. When you walk into that exam hall, you know you're battling against the clock and the immense pressure of the environment. If you don't have a bulletproof strategy for this specific 15%, you're basically leaving your final grade entirely up to chance. But we aren't going to let you do that. You're here to master this. I'm going to show you exactly what the examiners are desperately looking for when they scan your paper and how you can guarantee you capture this critical chunk of your overall score.
So here is our tactical roadmap for today's session. First, we'll unpack the 15% secret. Then, we'll build up your logical foundations, map out the standardized procedural sequence, master the art of critical evaluation, and finally, we'll crack open the principal examiner's trapdoor to reveal the most common mistakes you absolutely have to avoid. All right, let's jump right into Section 1, the 15% secret and core principles.
If you really want to grab this massive percentage of your paper, the very first thing you need to do is completely rewire your mindset about how you study mathematics. Capturing this 15% requires moving far, far beyond simple rote memorization. You cannot just memorize the formula for expanding a binomial, plug in some random numbers, and cross your fingers. The Cambridge exam is explicitly designed to break students who only rely on surface-level memory. They'll throw a question context at you that looks totally unfamiliar just to test if you actually understand the underlying mechanics. You see, the Cambridge assessment framework strictly prioritizes analytical depth over superficial breadth. So, what does that actually mean for you on exam day? Well, superficial breadth is just knowing a little bit about everything. It's knowing that I squared equals -1, writing it down, and leaving it at that. It's throwing broad superficial facts at the exam paper and just hoping the examiner finds something, anything, worth a mark. Analytical depth, on the other hand, is what actually scores the big points. The academic benchmarks for this topic demand logical, structured reasoning. When you are asked to find the square root of a complex number, let's say a plus ib, you must show the true depth of your understanding. You have to explicitly set up the equation x plus iy squared equals a plus ib. You must demonstrate that you know exactly how to expand that out. And crucially, you must show the logical reasoning of equating the real parts to the real parts and the imaginary parts to the imaginary parts, forming a pristine system of simultaneous equations. That flawless logical structure? That is exactly what the examiner is paying you for.
Let's move smoothly into Section 2, the standardized procedural sequence. This is where we transition from high-level theory straight into technical methodology.
Okay, pay close attention here, because this is the precise sequence of operations that examiners are actively hunting for when grading a top-band candidate's answer. Look at it from their perspective. When an examiner has to mark hundreds of papers back-to-back, they are craving a familiar, standardized flow of logic. If your working out looks chaotic, you are going to bleed marks. It's that simple. This 5-step standardized processing pipeline is your absolute survival guide under exam pressure. Step 1, identify key elements. Instantly extract those real and imaginary components straight from the prompt. Step 2, apply relevant principles. State your foundational equation clearly right at the top. Step 3, execute analysis with clear working. Now this is where you solve those simultaneous equations step by step, and please listen to me on this. Do not skip lines of algebra in your head. Write them down. Step 4, verify your results.
In complex numbers, you'll often end up with a quadratic equation that spits out multiple roots. You have to verify which roots actually apply to the specific constraints of the question. And finally, step 5, present the format. If the question asks for a complex number, your final answer must be cleanly presented in that classic x plus iy format. Systematically running your answers through this exact pipeline is what prevents those costly, careless errors when the exam timer is ruthlessly counting down.
I want to show you a direct quote pulled straight from the Cambridge Principal Examiner reports. Quote, "Even if your final answer is wrong, method marks can save you. Show working." End quote. I honestly cannot stress this method mark strategy enough. This is your ultimate safety net in the exam hall. Think about it. In a high-stakes math exam, you might accidentally drop a negative sign in step 3. It happens to the best of us. But if you just write down the final, incorrect answer, you get 0 marks, period. However, if you followed our 5-step pipeline and clearly showed the examiner your logical setup, your simultaneous equations, and your quadratic formula application, the examiner will happily award you method marks for the process itself. They are assessing your mathematical maturity, not just your ability to act as a flawless calculator. So show you're working clearly, and let those method marks carry your grade across the finish line.
We are now stepping into Section 3, Mastering Critical Evaluation. Honestly, this is where the top-scoring candidates completely separate themselves from the middle of the pack.
This is the exact moment we transition from simply getting the right answer to actually hitting those higher-order assessment objectives. Cambridge doesn't just want you to solve, they want you to evaluate. To conquer these high-tariff questions, elite students use the ultimate deconstruct, solve, evaluate framework. Look at how beautifully this expands on our previous pipeline. You always start by identifying the given information and deconstructing the complex problem into smaller logical steps. Remember, for multi-part complex number questions, Part A almost always feeds directly into Part B. Next, you solve systematically. But the real magic? That happens at steps 4 and 5. Checking for reasonability and making justified recommendations or conclusions based on hard evidence. When you find the square roots of a complex number, ask yourself, does the magnitude of my result actually make sense? If the question asks you to plot these roots on an Argand diagram, do they perfectly reflect the geometric properties you'd expect? You have to be evaluating your own output constantly.
The Cambridge marking expectations actually scale across 3 distinct frameworks. Let's break them down. At the lowest band, the descriptive level, you're basically just extracting basic data. You recognize it's a complex number question, and that's about it. Moving up to the analytical level, this is where you interpret relationships. You successfully set up and solve the algebra. Great. But look closely at the evaluative level. To grab those final, absolute highest marks, you must question assumptions, consider different perspectives, and explicitly justify your decisions. For example, why did you reject one of the roots from your quadratic equation? Was it because the question clearly specified x must be greater than 0? You must explicitly state why you made that mathematical choice. Evaluating alternatives and comparing approaches is the master key that unlocks those top mark bands.
Let's contrast these 2 approaches directly so you can really see the difference. Foundational data extraction is just reading the prompt, writing down the raw numbers, and blindly calculating. The top score mentality, however, means justifying every single decision with evidence. This type of student doesn't just calculate, they annotate. They'll write a brief, clear sentence saying, since the real part must be positive based on the initial domain, we reject x equals -3. That explicit justification, using hard mathematical evidence from the prompt itself, is exactly what the chief examiner is hunting for. Never, ever leave it up to the examiner to guess why you dropped a number. Tell them exactly why you did it.
Now, we need to talk about presentation because it matters immensely. The syllabus explicitly states that the presentation of information must follow strict conventions. This means you must use proper headings, correct terminology, appropriate formats, and clear annotation. If you are calculating the modulus, write the absolute value bars around z equals whatever. If you're calculating the argument, write arg z equals. Please, don't just leave random numbers floating in the margins of the page. Ignoring these structural rules will cause you to bleed marks through sheer ambiguity. Think about an exhausted examiner grading their 100th paper of the day. They are not going to spend 10 minutes trying to decipher a chaotic web of algebra. If your logic isn't clearly signposted with the correct terminology and formats, you will lose the method marks you worked so incredibly hard to secure.
All right, we have finally arrived at Section 4, the Principal Examiner's Trapdoor. Let's do a rapid-fire review of exactly where students historically forfeit their hard-earned grades.
We've thoroughly analyzed the global Principal Examiner reports for the 9709 syllabus, and let me tell you, the data is incredibly clear. There are specific traps that catch thousands of students every single year. You need to make sure you avoid these 3 fatal examiner warnings before your exam timer runs out. Warning number 1. Answers are too vague. When an examiner writes this in the report, it means you skipped crucial steps. You didn't show the explicit expansion of your binomial, or you completely failed to state the simultaneous equations clearly. You just jumped straight to the roots. Never skip the specific details. Warning number 2. Forgetting to check format and presentation. Imagine doing all the brilliant complex math to find x and y, but then you forget to write your final answer as x plus iy. You essentially answered a question they didn't even ask. And warning number 3. Answers are not specific to the given context. This means you blatantly ignored domain restrictions or specific conditions set in Part A of the question when you were solving Part B. Always tie your final answer back to the exact context of the prompt.
So I have to ask you, are you actually applying this deconstruct, solve, evaluate framework to your past papers right now? Because listen, it is not enough to just passively watch this explainer and nod along. You have to actively implement this playbook in your very next revision session. When you sit down with a past paper later today, don't just casually solve it, deconstruct it, map out the logic step by step, write out your explicit justifications, audit your own presentation like you are the examiner. You need to train yourself to write exactly the way the examiner wants to read.
And that officially wraps up our deep dive into the examiner's mindset for complex numbers. To make sure your revision feed is perfectly optimized for the entire syllabus, take a quick second right now to subscribe to @AceTheExams. We are dropping weekly Cambridge exam breakdowns just like this one to help you maximize your mark yield. Head down to the comments right now and tell me exactly which Cambridge subject or even which specific topic you are gearing up to conquer next. Stay focused, keep rigorously analyzing those past papers, and I will see you in the next explainer.